So I decided to go over the PowerPoint that we went over today in class. And so this is just a review of all types of angles. So for number one, what you need to notice is that this is an inside angle. It does not have the center marked. The center, this point at that point right there is not your center of your circle. It's just four angles. Next thing you need to realize, so this is an inside angle, and the formula that goes with an inside angle is where you take the angle, you have both of your arcs, add them together, and divide by 2. So that's the formula that fits with an inside angle. So this is inside. So next thing we need to make sure that we have is that the two arcs that are associated with the angle we're actually looking for. So I usually draw that straight line to show that those arcs are connected to the angles that I'm looking for. And then the next step is just to go ahead and solve it. You got 148 plus 38 divided by 2. And I don't have the answer, so it'll take me just a second to actually solve these. So the answer would be 93. 93 degrees. Okay? Alright, erase that. Go to the next slide. My next slide, practice problem 2, is, whoops, I still didn't get it. Why aren't we turning here? Alright, here we go. We have another inside angle. Now this one looks a little bit like the center, but there is no dot saying that's the center, so you cannot assume that it's the center. What you've been given is an angle. You've been given an angle, and you have to find an arc, so you're missing. So we have the fact that we have to find an angle. We have our two arcs, and we need to divide by 2. So if I write the formula every time I do one of these problems, it may help me actually know what's going on when the test comes on Friday. So 86 is equal to, because that's my angle, so I'm going to put it where the angle goes. I have x for one arc, and I have 104 for the other arc, divided by 2. So all I have to do is follow the formula that is given for an inside angle, and put in the pieces that you're missing. So I'm going to multiply both sides by 2. And when I do that, I get 172 is equal to x plus 104. So all I have to do is solve that for x, and when I subtract that 104, I get 68. So x is equal to 68. Okay, so 68 is the arc. It is not the angle. You need to be careful when you're given the angle and when you're given the arc. Alright, next one. Now this one is an inscribed angle because it sits on the circle. It actually is on the circle itself. So this is called inscribed. Inscribed has a formula, and the formula is where you take the angle. Well, if you're given the arc, you divide it in half. If you're given the angle and you want the arc, you have to multiply the angle by 2. Okay, so we're actually given the angle. We're given the angle, so that means I'm going to take 42 and I times it by 2, and I'm going to get 84. So when I go from this small area to a larger area, I have to multiply by 2. Okay? You're always multiplying by 2. That's an inscribed angle. My next one is a central angle. It's in the center. It has a dot. It tells you that it's in the center. When you have a central angle, they are equal to the arc. So there's no hard work to this one. So if this center angle is 98, then that arc is 98. Alright. We got another, this time my angle is on the outside. So if it's an outside angle, there's another formula. And the formula says if you want to find the angle, you have to take the big arc, the larger number, subtract it from the smaller number, the smaller arc, and divide by 2. So in this particular problem, I've been given my big arc, and I've been given my small arc. So I just have to plug it into the formula to find my angle. This is the angle. It's on the outside. So if I do that, I've got 84 minus 20 divided by 2. So 84 minus 20 is 64. 64 divided by 2 is 32. So that angle is 32 degrees. Okay? Alright, moving along here. The next problem practice problem 6. Now on this one, I have an outside angle. I have one arc, but I'm missing an arc. Okay, so what I need to decide, this is outside, that means I have an angle, I have to have my big arc minus my small arc divided by 2. So I've got the 15, that's my angle. I've got the smaller arc. I know it's smaller because it looks smaller. So I need x as my big arc, 35 as my small arc, and then I have to solve for x. Okay, and that will give me my big arc. When I do that, I have to multiply both sides by 2, and I get that 30 is equal to x minus 35. And then I add 35 to both sides, and I get that arc we are missing, the big arc, is 65. Okay, so if you use the formula and plug in for the formula for the pieces that you know, you just solve for the one that you don't have, which is your x. Alright, next problem. Next problem is a type of inscribed problem. It's inscribed because it sits right on the circle. The vertex of this angle is on the circle. So that means that angle is 150. If I'm coming out here to my arc, remember if I'm going from a smaller place to a larger place, I'm going to multiply by 2. So that means this arc is 300. So remember, this is inscribed. Inscribed means when you have the angle, you take the arc and half it. Or, if I'm looking for the arc, I can multiply both sides by 2, and that means I take my angle and multiply it by 2 to get my arc. Okay? Inscribed. 150, double it, you get 300. Alright, next one, 174. Now, what I told you in class is that you're going to be able to write on your test. I'm going to give you a colored pencil. I want you to actually mark what you're looking for. So first off, this is an inscribed angle, but I'm actually looking for the arc that is not related to that inscribed angle. I'm going to do this one 2 ways because, you know, with circles there's just so many ways to do it. You can look at that and know that it's inscribed. Excuse me. So you know that you take 174 and you double it. You get 348. Alright? That 348 is for this part of your circle. Okay? It's for that part of your circle. You're looking for this part. Well, it's only 2 parts to that circle, so you can take 360 and subtract it from 348, and you get the missing arc. You get what you want, and it's 12. Okay? So you need to be really, really careful about what the questions are asking for. Alright, so if that's 12, now I'm going to show you a second way to think about this problem. Okay? Remember that a straight line is 180 degrees. I have 2 sections to my straight line, and the one section is 174. If I take 180 and subtract 174 from it, I'm going to get 6. So that means this inscribed angle is 6. And if I want that arc that goes with that inscribed angle, all I have to do is double it, which is 12, which is exactly what we got the last time. So that's an inscribed angle. Think of it as a big puzzle. These are fun. These are puzzle pieces. Here we're back to an outside angle. So this is outside. Keep doing that. I'm sorry. Go away. All right, this is an outside. So that means I'm going to have my angle. I'm going to take my big arc. I'm going to subtract my small arc, and I'm going to divide by 2. So what pieces was I given? Well, if you look at it, that 284 is your big piece, and your angle is what you're looking for. So you have 284 minus your small arc divided by 2. But do you notice you have 2 variables that you're trying to solve for? You can't do that. So what I have here is that this 284 goes to this big giant arc. And what you need in order to solve an outside angle is the small arc, this piece right here. So with that piece right there, can't I take 360, because the circle is 360, subtract it from 284, and you get 76. So now I have my small arc in order to find my angle. So if I take 76 and plug it in for my small arc, I can do 284 minus 76 divided by 2, and you get 104. Now let me say something. If you just did what I did into my calculator, if you put this whole thing in your calculator at one time, you need to make sure that you put that top section in parentheses and then hit the divide button. For me, it's easier just to put the top section in, hit the enter key, and then hit divide 2. That way I don't have to worry about parentheses. But if you want to do it all together, the top piece has to be in parentheses. Okay? So you get 104. Next one. Number 11. Alright, it's practice number 10. The slide is number 11. Alright, so if I do this one's a little bit different. The circle test is all about diameters, semicircles. What do we have? First, I guess we need to realize that this is an outside angle. It's on the outside. So that means I have my angle is equal to my big arc minus my small arc divided by 2. My angle is x because that's what I'm looking for. I don't have my big arc, but I have my small arc, and I can divide by 2. Now I got too many unknowns. What I do know is that that's a semicircle, and with semicircles they add up to 180. Semicircle is 180 degrees, right? So if I have 50, then I can figure out what this portion is by subtracting it from 180. So now I have the fact that my big arc is 130, and I can come over here and I can solve for that. So 130 minus 50 gives me 80, and I divide that by 2, I get 40. So my angle is 40 degrees. Okay? We're trucking along here. Alright, next problem. There's quite a bit of these problems. This is the same thing. This 120 represents the small arc. This is an outside angle. It represents this small arc. What I need is my big arc. I need this piece over here. So if I have my small, and there's only 2 pieces to this circle, I can take 360, subtract from 120, get 240. So my outside piece over here, my big arc is 240. Now I can take 240, I can subtract 120 from it, and divide by 2. So 240 minus 120 is 120 divided by 2 is 60. So 60 degrees for my angle. Alright, so you're going to have a lot of these types of problems on your test on Friday. So hopefully you are studying. Here's the next one. This one actually gives you the angle. It's an outside angle. This is outside. Alright, so you've got outside. That means I'm going to put it in the spot of my angle, and I'm going to take my big arc and subtract my small arc and divide by 2. So when I do that, I got to get rid of the 2 on the bottom. So 2 times 2 over here, these two things cancel. 2 times 40 over here gives me 80. 80 equals 110 minus x. So then I subtract the 110. And remember, you can never have a negative degree. So I've got negative 30. Wait, you just said I can't have that. But you've got this subtraction sign hanging on to that x. We're going to treat it like a negative 1. I have to divide that off. My x has to be by itself. So really, in reality, you have an arc that is 30 degrees. Okay? So just remember, if you happen to see a negative answer on your test, you can laugh at it and go, ha! No way, can't have negatives. Alright, next one. Here's another one, semicircle. Semicircle, 180, so here's my semicircle. Alright, here's my arc. This piece is 120. What's this piece over here? 180 minus the 120 is 60. So that arc is 60. This is an outside angle. So then 120 minus 60 divided by 2. So that angle is 30 degrees. Okay, we got a lot of these we're practicing. Alright, next one. We got another one. If that piece is 300, then this piece is 60. Because 360 minus 300 gives me 60. So it's an outside angle. 300 minus the 60 divided by 2 gives me 240. So 240 divided by 2 gives me that my angle is equal to 120 degrees. Getting kind of easy, right? We got another outside angle. I'm not sure why I put so many of these in here. This one's the easy one. It actually gives you the arc for both of them. So you have 258 minus 30 divided by 2. So 258 minus 30 is 228. 228 divided by 2 is 114. So that angle is 114. Outside angle. Subtract the arcs. Alright. 16. Oh, finally, something different. I've got two things going on with this problem. Okay? You're going to use that 168 to help you solve for x. Alright, so once we do that, what I have is a central angle. This is in the center. So if that's in the center, that means this arc that it intercepts is also 168 degrees, right? Okay, but I want to solve for x. Well, that x that I'm solving for is an inscribed angle to that 168 degrees. So all I have to do is I'm going from a larger area to a smaller area. I can divide by 2, and my answer is 84 degrees. So it's not so bad. 168 divided by 2, 84. Okay? So you're going to see these again. Make sure you understand. Go ahead and hit the back button or pause it. Just make sure you know how to do these. The next one, number 18. Now with these central angles, you really need to watch for diameters, for 90 degrees, for semicircles. You know, the diameter cuts the circle in half, 2 semicircles. So when I look at this one, I see that 140, and I know that this arc is also 140 because it's a central angle. Well, what I want to look at is that that's a diameter. So this whole piece right here is worth 180 degrees. So I can say, okay, I've got two parts to my 180 degrees. 6x minus 8 plus the 140 has to add up to 180 degrees. So I use that to help me solve. So if I add together the 140 and the negative 8, that gives me a positive 132. And then I subtract that 132. That gives me, I believe it was 48. Let me double check. 180 minus 32 gives me 148. Not 148, I put that in there wrong. It will give me just 48. And then 48 divided by 6 is 8. So your x is equal to 8. Can I check myself? Sure. You've got 6 times 8 minus 8. So that's 48 minus 8. This is 40, which is good because that's 140. And you add the two of them together, you get 180. Perfect. Just what you want. All right, we got 3 more problems. You've got this situation where you have 2 chords that are equal. If those chords are equal, the arcs that they intercept, which means these two, are also equal. That's what that means. So if these two things are equal, then these are equal. So if BE is 98, that definitely means that CD is 98. Okay? You just have to remember the little rules that come along with this. Alrighty, next one. We got a polygon inscribed in a circle. So in order for it to be inscribed in a circle, all the corners have to touch the circle, in which this one does. But there's a rule we learned that opposite angles in your polygon have to add up to 180 degrees. In order to be inscribed. Okay, so in order to be inscribed, these opposite angles have to add up to 180. So this makes it pretty easy. X and 105 are opposite angles. So X is going to equal 180 minus 105. So X is equal to 75. And you turn around and do the same thing for the other one. So you have 180 minus 86, which gives you 94. So your Y value is 94. Oops, hold on just a second. I'm making sure I did that correctly. Yep, 94. Okay? Opposite angles have to add up to 180 degrees, no matter what. If they do not add up to 180 degrees, then they are not, the polygon is not inscribed in the circle. Okay? So just remember that. Alright, last one. Let's see here. Whoops, here we go. There was a number there on that green square. So I took it away and put a different number. We need to realize, and this is quite a few times now, we need to realize that these are, A is an inscribed angle, B is inscribed, and this little angle over here all by itself is inscribed. This is inscribed. And what it's inscribed to is the diameter. See this diameter right here? So that means this is a semicircle. So if this is a semicircle, it's worth 180. That means this inscribed is 90. Okay, that will always be the case, always. Plus it looks like 90 degrees. If you make an educated guess on these triangles that are within these circles and it looks like 90 degrees, you're probably going to be correct. Now, I know that this angle is 43. How am I going to find that missing angle? What do we know about triangles? They add up to 180 degrees. So if that's the case, I have 2 out of the 3. All I have to do is take 180 and subtract the 90, subtract the 43, and that's going to give me that missing angle. So you can take 180 minus 90 minus 43, and you get the missing angle to be 47 degrees. Okay, sounds good. If you know all these things and you have look over your homework, make sure you know how to do your homework. I'll have tutoring. You know when I have tutoring, Go ahead and come see me if you have questions. And good luck. Test is Friday.